In this video, we'll begin working on finding exact values of composite functions with inverse trig functions. Remember, composition functions are functions inside of functions. So look here. Notice that that inverse sign is inside the sign, right? I don't have sine x, inverse sine x. I have sine x, parentheses, with the inverse sine x inside of it. So let's take a look at, I have directions here if you'd like to use those, but I'm just going to jump straight to the examples and talk through them because usually when I read instructions like that, people glaze over. So we do this starting on the very most inside and work our way out. So I'm going to do the sine on the inside first. So I have to do sine of pi over 3, right? This part right here. That's inside the other one. Sine of pi over 3. Okay, pi over 3 is our, in quadrant 1, and it's our tall triangle. And we're talking about sine, so sine is y, so that's going to be my tall side, the big side, so it's got to be radical 3 over 2. All right, and then now we have to make sure that our answer is going to come out of negative pi over 2 to pi over 2, because inverse signs, that's where they land, right? It has to be in quadrant 1 or 4. So sine is y, and it's positive, so I know it's going to be in quadrant 1, right? And if I'm following that logic, quadrant 1, and I need radical 3 over 2, that is y. Sine is y, right? So radical 3 over 2 is my big side. So I'm going to have a triangle with radical 3 over 2 on the big side. That's my tall triangle. So this would have to be pi over 3. Now you're asking, well, don't those just undo each other to get you pi over 3? Yes, kind of. And no. So let's take a look at it. Number 2, this is going to show why it doesn't always work out like that. All right, so I'm first going to do the inside sine inverse, and then I'm just focusing on this part first, very most inside. Sine of 2 pi over 3, that's the triangle on the other side like this. So the y is positive still and still going up. I'm going to have radical 3 over 2. Now, again, sine, when I go back for inverse, it has to land here. 2 pi over 3 was not in the first. Remember, this right here is quadrant 1 and 4. 2 pi over 3 is quadrant 2. So it's not going to land back there. What's going to happen is we're going to get pi over 3 because sine has to land in quadrants 1 or 4. Well, if you see, this is the exact same as that. Those answers are going to have to be the same. So, with what I was saying a second ago, unfortunately, having an inverse sine doesn't always just cancel each other out to get the 2 pi over 3. All right, let's take a look at 3. All right, 2 pi over 3. So we'll deal with the innermost first. Cosine of 2 pi over 3. Well, 2 pi over 3 is in quadrant 2, and it's also my tall triangle because it's a third. Cosine is x, so we're going to get inverse cosine, and it's the small side to the left, so it's going to be negative 1/2. Right? Cosine, if you remember, has to land, inverse cosine has to land back 0 to pi, quadrant 1 and 2. Well, x is negative 1/2 in quadrant 2 at 2 pi over 3. So this still has that same answer. But let's take a look at 4, because I'm sure 4 is going to lead us astray, show us an example where we can't just take the middle number. All right, so taking this cosine of negative pi over 3, right? Okay, well, negative pi over 3, that's in quadrant 4, and it's going to be my tall one. And cosine is the small side, so that's 1/2. So this thing is equal to, I have to go down here, cosine negative 1, 1/2. Right, because it's to the right. Now, if I do cosine, when is cosine 1 over 2? Well, that's not going to be back to negative pi over 3 because it has to land back in here, 0 to pi in the first 2 quadrants. Cosine is positive in quadrant 1, so it's actually going to be pi over 3, not negative pi over 3. Up here are rules for how to make these like land where they're supposed to. I would recommend reading through those now that you've seen how these work. All right, we have to do now one more, and then we'll move to the next video, which is going to do like a sine and an inverse cosine, stuff like that. So let's evaluate this first one. Right, this is going to be a bit tricky. I think I'll need my calculator because pi over 8 is not in my graphing, in my unit circle. So let me open this up. Right, and we're in radians already because I worked with it in a previous video. So I'm going to do tangent of pi over 8. Pi over 8. And it's definitely going to give me a decimal. So I got tangent, and since I'm going to be working with this again, I'm going to write out the whole thing. 0, 4, 1, 4. 2, 1, 3, 5, 6, 2, 3, 7. All right, now inverse tan. Right, when I do this, well, I just have to plug it in. So we'll do inverse tan. And remember, this has to land between, in open parentheses, negative pi over 2 to pi over 2. Has to land back in there. Okay, so let's do it. Inverse tan of 0.414213562237. I could have done answer, but I think I lost it already. Okay, so this tells me that this answer is roughly 0.3926990,817. That lands in there, right? Pi over 2 is like 3 cut in half. It's like 1.6, 1.5-ish. So this lands me back in there. So we're all good. Now let's do it this way. We have another one, tangent -1 of tangent 11 pi over 9. So we're going to plug that in, tangent of 11 pi over 9. And we get roughly inverse tan of 0.839099631118. Now I'm going to plug second tan. Oops, this is what happened last time. See if I can do that over again. 11.9. Let me get to the next line. Enter. There we go. And then now I'm going to do inverse tan of that answer, second answer. And I got roughly 0.839099631118. We'll leave it there. Now, one thing I want to check is let's do 11 pi divided by 9. And notice it didn't like undo itself. But pi over 8. Oh, that's because it's in the same line. Hold on. Pi over 8 gets me that first answer. Notice that came out as the same. Pi over 8, same number. But this one came out as two different numbers. And again, this works just like that sine and cosine. Because of our domain restrictions, it messes with these composition functions.